Today we're going to talk about contactors, how they work, what they do, why we use them. Uh, Really common. You'll see them anywhere from your home air conditioning system to your septic system. It's used as almost a safety device, as a way to break your live and neutral circuits, so that downstream you're clear of electricity while servicing or working on components. It's not to be confused with any type of disconnect or safety switch, but it is called for in a lot of motor applications. Uh, there's a lot of information that can be found on the device itself. This one's made by Eaton. This one's a two-pole, and by two-pole it means that it allows two passes to go through the switch. A one-pole would be very similar, but it would allow you to pass through your live wire, and then your neutral would just either have a shunt, which would be just a piece of metal connecting this screw to this screw, uh, or it wouldn't have anything at all. You'd still make the contact anyway. Um, so neat device, and if you ever worked on an old tractor and an old point system, then you probably have a good idea of how it works. Uh, so this is, like I said, it's a bus bar that goes through. There's a coil, like a transformer, that's down here, and once you apply power to the coil, it's going to suck in a magnet, energize the magnet, and it's going to close it. And that's what these buttons here are. You can push down on that, and you can manually close it without applying power. So it can be tested with a multimeter. But we have a test box here. We'll run through that first, and we'll show that. So these test boxes, we'll talk about that for a second. Um, these aren't available at the store level because, to be honest, they're inherently dangerous to use. Uh, you kind of have to have live circuitry here while you're doing with it, and well, it's just not safe for most levels. Uh, So using this box and as a demonstration, we'll put it on the post so it's firm because it will move a little bit. Uh, these two wires simulate the power coming in. They give you a couple different choices. You can run power straight to your screw. You can run spade connectors. It doesn't really matter which one you use. Uh, the only thing that really matters is that if you put your live on this side, that your live is going to have to be on that same side. You can't cross circuits, right? So we're going to connect those. We're going to make sure it's not touching. Good contacts. These two wires, they simulate our 110 volts going to the coil, and that's what we're going to use to engage and disengage the contactor. And these, it doesn't matter which way you put because you're just passing through. You can put black on the A1 side or the A2, doesn't matter. Again, just make sure it's a good connection. It's not going to fall off or anything like that. So we're all connected up. So once we turn it in, again, this test box, it's going to be a live circuit all the way to here. It's nothing past here, and we're not going to see any voltage here. Once we energize it with the control switch, that's any type of, that can be a float, it can be a timer, it can be whatever it needs to be to allow power to come to these sides and allow ultimately power to pass through the contactor to the motor or pump or whatever it is. So once we plug it in, these will be live. These will not have any power. We won't have any power there. So let's go ahead and plug it in now. So we're plugged in. Again, it's live. There's no power coming through. So we can test it two different ways. One, we can manually push the contactor closed, which will bypass the coil in there. So if there were a problem with the coil itself, we can still test it by pushing it. And we have electricity coming through. You can see, it's hard to see on your screen, but about 119 volts. Let me see if I, yep, there you go. So once we release that, it goes away. So we can also use our control switch. Let me tilt it up for you. So once we engage it with the control switch, that coil is going to energize the magnet. It's going to suck it in. So not only are you going to see voltage here on our indicator, but you're also going to see these contacts suck in. One thing you're going to listen for is just a clear, succinct noise once it engages. No humming or buzzing or anything like that. If you hear that, the coil is on its way out. It needs to be replaced. So we'll go ahead and engage the control switch. And you observed as those sucked in, and we now have voltage. There's no extra noise coming from it. So once we turn it off, the coil is going to release, and we're going to lose voltage. And that's how we know we have a good coil. So what we can do now, that's off. I'm going to go ahead and unplug it. So now our circuit on this side is dead. We'll take all this good stuff off, and then we'll use a multimeter to test it as well, which is something you can definitely do at the store level. So the same settings as before, we'll just set it to continuity. So you can test one side at a time. So if we test our multimeter, we'll get tone when we make the connection. So if we're on leg 1, which is where we had the black or live previously. If you go top, let me make sure I'm on there, to bottom, you're not going to have any continuity because the coil is not energized and these haven't sucked in. So if you take your screwdriver, and this is safe because there's no electricity, and we manually push this in, you're going to get continuity because that's going to allow power to pass through. You let it go and it still works. So we do it on leg 2 just to satisfy our curiosity, and we do the same thing. So that's as far as you can test them with a multimeter, except going through the coil. But it's a great way to make sure we're doing as much as we can to help people from wasting money or replacing the wrong components. So, like before, if you have any questions, reach out to your manager and they'll get you sorted out and on the right path.